Hi, today I'm going to do lesson 3, module 3, lesson 5, completing the quadratic equations by completing the square, solving quadratic equations by completing the square. Okay, so we're going to solve equations. So when we solve quadratics, remember we're looking for those x-intercepts by using the square root property, and then we're going to complete the square. So that gives you a hint with the square root property, what that means. And then we're going to interpret key features, because if you have the vertex, the zeros, you know which direction it opens, you could sketch the graph really quickly. So we're going to complete the square. Vertex form, I didn't spend much time on transformations this year, but that is vertex form. H is the left and right, your x component, and k is your vertical. So if you have it like this, h, k is your vertex. Also, we're going to talk about projectile motion problems, which would be like Angry Birds, which would be like throwing a baseball, a diver on the high dive, anything that you're going to start and go down and then land on the ground. Never go below zero on those. Okay, so square root property. That's where we're going to solve it first. So you need to be able to recognize perfect squares. Take the square root of each side to solve, and then you have your solution. So let's just jump in and do example 1. Rational roots. So these are perfect squares. Now, let's talk about what a perfect square trinomial is. We know what a perfect square number is, but a perfect square trinomial. And we did it last lesson 2. So that's when you have, for example, if I have x squared plus 8x plus 16. Well, that factors to x plus 4, which is x plus 4 squared. How do I know that? Because 16 is a perfect square, the square root of it is 4, and the middle is 2 times 4. Now our a is 1 here, so it's actually 1 times 4 times 2 is 8, but that is a perfect square trinomial. Perfect square trinomials have a plus right there with the c, and your b's could be plus or minus. If it's a negative, then your factors are negative. So let's solve this with the square root. First, you want to recognize this is a perfect square trinomial, so you get this factored. Then take the square root of each side, and when you take the square root of each side, that cancels out with the square. Square root of 25 is a plus and a minus 5. So your last step is just to add 2, and you know these two numbers. If you could solve that, don't leave it like that. You know 2 plus 5 is 7, or 2 minus 5 is negative 3. You could write your answers like this. You could write your answers like this. You could write your answers like this. Or x equals 7, negative 3. But do not write your answers with parentheses, because that's a coordinate point, and these are two different points. All right, let's do the check. So x squared, so since this is 38, I know that's 2 times 19. 19 squared is 361. I believe 576 was 23. So the left side factors to x minus 19 squared on the outside. Square root of 576 is 24 squared. So if I take the square root of both sides, I get x minus 19 equals plus or minus 24. Add 19 to both sides, x equals 19 plus and minus 24. So we have two answers. 19 plus 24 is 43, or 19 minus 24 is negative 5. So you need to recognize that this is a perfect square trinomial, because if you were to move the 576, it's not going to be a square anymore, and you can't take the square root. So here's one with irrational roots, which means we're going to have a radical, the square root sign, and not be able to solve it. We're going to have to simplify it. So 12 squared is 144, and 2 times 12 is 24. There's both plus, so this is the factor of that. 192, so we're going to take the square root of each side. 192 is not a perfect square, but by this, since they got out 8, it's 64 times 3, so they took out the 8. And then once we minus 12, there's our answer. It is fine to leave it like that. You could write it separately if you'd want, but it is fine to leave the plus and minus. Now, when would you need the decimals, which they gave us here, 1.86 and negative 25.86? You would have to put that in the calculator for the plus and the minus and get these two decimals if you are graphing and need the exact zeros, okay? Because these are the two zeros where this parabola opens. So, I'm going to show you here. I meant to show you on the first one, but I will show you here. The other thing in this lesson is vertex form. So as I briefly said in the definitions, I'm going to come over here. Vertex form is ax minus h squared plus k, where h and k are our vertex. Now, where do we do that? From right here before taking the square root. So I'm going to rewrite that down there. X plus 12 squared equals 192. So to write this in vertex form, you got to get everything to the one side. X plus 12 squared minus 192 equals 0. This is vertex form of that parabola. So here are your zeros. We're going to find our vertex here. You know it opens up because A is 1, and you could sketch the parabola. Now the thing with this, h in our formula is a negative. So h here is a negative 12, okay? Because it's negative is a positive h. So h is negative 12, k is negative 92. You only change the one inside the quadratic. So our vertex here is negative 12, negative 192. So like I said, negative 12, negative 192, I'm going to make up that this is it. Our zeros are 1.86 and negative 25.86. Oops, it's not very centered. Maybe I'll do it right there, because half of 25 is about 12. So then you go up and then you go up. Your y-intercept on that would be, you'd have to do 144 minus 192 to get your y-intercept, your c. So 144 minus 192 to get the equation all on one side is, I'll put it here. So y equals negative 48. That's your y-intercept. Okay? So you could sketch it really easily with vertex form. They go over it a little later, but I just want to show you every time we do it. So here's one with complex solutions. Again, well, this one is not a perfect square because we have a 2. If this 2 was a squared number, we could probably factor a perfect square. But looking at this equation, if I divide everything by 2, because these are all even, we get this. We get smaller numbers. So now, half of 46 is 23, and 23 squared is 529. So it's x minus 23 and square root of 36, so we take the square root. Now this is an imaginary number, right? Square root of negative 1 is I, so there's going to be an I there. Square root of 36 is 6, so that is your answer. You have to add 23, and you could leave it like that. I would not write it out separately. 23 plus or minus 6i. Now let's do the vertex on this one, which I'm going to write this down here. So vertex form is x minus 23 squared equals negative 36. So x minus 23 squared plus 36 equals 0. So see how this is negative? Our h is 23. Our k is also positive. Remember, inside it's opposite, so that is our vertex. Now, it makes sense to have imaginary zeros because 2336 is up here and it opens up, so it doesn't cross the x-axis at all. So that's vertex form because this is our vertex. You need to just get 0 on one side for the vertex form. Okay, now we're going to complete the square. Those were already perfect squares, so now we're going to complete the square. We're going to make something into a perfect square trinomial. It's very simple if you follow these steps. First, identify A, B, and C. And then you take half of B. And then you square that number. Okay? Because why? That's B and half of B squared. So when I was over here, there's B is 46, half of B is 23. This is 23 squared. That's how I know it's a perfect square. Now these that we're going to do now are not perfect squares, but we're going to force them to be. But always start out with finding these values and you won't go wrong. Okay? This one has a C instead, but we're going to just go on with the real stuff. Here's one. This is not a perfect square. So I have A is 1, B is 18, C is negative 4, which is fine. Half of 18 is 9. 9 squared would be there. So what we do first is move the 4. Move the 4. Then we have 18 is our B, so half of B is 9, and half of B squared is 81. So to make this a perfect square trinomial, if this was 81, that's a perfect square trinomial. But whatever I do to this side of the equation, I have to add to this side. This factors to that. This becomes 85. So now we force that to be a perfect square, but since we're going to add later on, we're going to add and subtract, or adding the same thing to both sides of the equation. That makes it equal. Take the square root, minus 9. Go ahead and leave your answer like that. Square root of 85. 85 doesn't have a perfect square that divides into it, so that is simplified all the way. There it is. Now, I'm going to work on vertex form on this. So right from here. So vertex form. You could do that. You could also go from there, and I'll show you another way later. You still have to work with the 81, but there's vertex form. So my vertex, since that's a positive, is negative 9. This stays as it is. There's my vertex. Okay. Example 7. We're going to complete the square on this, but this one, 4 is a square, but it's really a lot easier when we have an A of 1. So we're going to divide everything by 4. So we're going to get a fraction. So we're going to get, divide that by 4, that by 4, that by 4, 0 by 4, we get this. So now our A is 1, B is negative 3, and C is negative 27 over 4. You could convert that to a decimal because it's rational. It doesn't extend, so 27 divided by 4. But I'm going to do it with the fraction way because usually it works out. 6.75. So B is that. Half of B is negative 3 over 2, half of that. And half of B squared, square that, 9, square 2, I get 4. So we're going to add the 27.4 to move it to the other side. We're going to add in our B squared, 9 over 4. Add in 9 over 4. See, these are both over 4, so they have a common denominator. This factors to the half of B, negative 3 halves. They already had the negative there, so I put the negative. So your factors is the half of b. Your c, your new one that you add on, is that one. 27 plus 9 is 36. 36 divided by 4 is 9. So see, our fraction worked out. So we get square root, plus or minus 3 is the square root of 9, and then move the 3 halves. So 3 halves plus and minus 3. Now that is a fraction, but it does work out to be rational because 3 halves is 1.5. So you have 1.5 plus 3 and 1.5 minus 3, which is negative 1.5. So those are your two answers. You could write them as decimals, which you would use for graphing, or you could keep them as fractions. Let's go to this one and write the vertex form. This one's a little different because of the 4. I don't think I divided before. No, I didn't have to divide out the number. So this one's a little different because of the 4. What happens to this one is that we need to multiply the 4. And when we add to the other number, we have to multiply it by 4. But I'm not going to do this one right here in vertex form. We only did the vertex form when a is 1, and I'll show you that in the next section. Okay, complete the square. So 6, see, there are other ways to solve for the vertex and other ways to find zeros that I would not use completing the square for this, because 6 is not a square. You have to divide 21 by 6 and 9 by 6, so I'm going to skip the check. Okay, let's go to this one. 3, sure. We could divide everything by 3. 465 divided by 3 is 155. So we get 155. 72 divided by 3 is what? 12? No, 24. 2 12s. Okay, so now we minus 155. We get b is negative 24. Half of b is negative 12. So this is our factors. Half of b squared is 144. So we're going to add 144. Negative 155 plus 144 is negative 11. Take the square root, we get an I, but 11 is not a perfect square, so it just stays there. So we get 12 plus or minus square root of 11i. Remember, the I is written in front, not behind, to make sure it's not under the radical. Again, I'm not going to show you vertex form on this because we had to divide out that 3, and what is going to happen is going to be 3, where is it, x minus 12 squared. The only thing is, I think it's 3 times this when you move it over. So anyway, okay, so let's talk about vertex form now. Vertex form is getting in this format. Minus h is the standard, so that would be a positive h, and k is whatever sign it is. So if you have something like this, a plus 3, then your h is a minus 3. You take the opposite, okay? And these are trajectory problems, which you talked about before. If you're in physics, you've seen this with gravity. Gravity is 9.8, so you'd plug that in. Starting velocity, starting height. In physics, that's the starting, I don't remember right now the initial height, but I don't remember what they call h0. And starting velocity. And you would plug those in. But let's go to vertex form. So here is 1, but a is not 1. A is negative 1. So we're going to factor out a negative, which they did not do out of all of them, which is fine. So they separated out the quadratic and then the minus 9, kind of like we did before, but we had moved minus 9 to the other side. Since we're looking for vertex form and not solving, we're going to leave the minus 9 there. So my b is 12. I'm using this one after we factor it out. Half of b is 6. Half of b squared is 36. So we're going to add 36. But remember, we're adding not only 36, we're adding this negative. So we're adding a negative 36. So we got to make sure and subtract, because we're going to do it all on the same side of the equals. The other one, we moved it over to the other side, so we're just doing the same operation. This is all on one side of the equation, so we're going to add a negative 36, and so we have to subtract a negative 1 and a 36. Okay, so this is adding it in, this is taking it away, subtracting. So then this factors to half of b. That one's good. Now here we get negative 9. This becomes a plus 36, which is 25. So there it is. There's vertex form. Now your a is negative 1. So that's going to open down. Your vertex is negative 6, 25. I guess I could zoom in a little more. Okay, so let's do this one, because you don't have to factor anything out in this one. I guess we could do both. So I'm going to come over here to the right-hand side. Our first one is x squared plus 8x. Leave a space and then put minus 3. So our b is 8, half of b is 4, half of b squared is 16. So that's what we have to add in. So we're going to do x squared plus 8x plus 16. Then we have the minus 3. Since we added 16, we want to also take away 16. 16, subtract it. So 16 minus 16, we're not changing it, we're just adding 0. This factors to x plus half of b squared, and this is negative 19. So that's it for that one. So x plus 4 squared minus 19. Our vertex is negative 4, negative 19. Remember, inside is opposite. Let's do the next one, b. Maybe we could see it both. So b is negative 3x squared minus 6x minus 5. So I'm going to factor out the negative 3 just out of these two, plus 2x. Close the parentheses, put negative 5 over here. This is my b that I'm going to work with. Okay? So I just factored that out because this, and I moved the 5 there. So my b is 2. Half of b is 1. Half of b squared is also 1. So I have to add 1. And if I add 1 there, I have to take it away. But I didn't just add 1. I added negative 3 times 1. So you have to take away a negative 3 times 1. So this side factors to negative 3x half of b squared. This is negative 5 plus 3. So our final thing is negative 3 plus 1 minus 2. So our vertex is negative 1, negative 2, but our a is negative 3. So that one opens down. Oops, I'm so sorry. There is that. Negative 1, negative 2, because that's the opposite in your k. This adds to 2. So remember to subtract your a and your c, because we have that over here. We didn't just add 1, we added 1 times negative 3. Axis of symmetry, think of the vertex. The vertex is the axis of symmetry for h, and then your y is your y value. So your axis of symmetry, since your vertex is 2, negative 7 here, your h is 2. Find the vertex if it's a minimum or maximum. Well, the vertex doesn't have to do with minimum or maximum. That's your vertex. What deals with minimum or maximum is your A value, this value right here. So A is positive. A is 3, it's positive, so it's a minimum. Opens up like that. Okay. Here's one with a quadratic function. I don't want to do that. I'm sorry I don't have all the problem numbers right here in front of me. So look online or on my calendar in class and let me know if you have any questions. Thanks.